Okay, we are in section 3.8, last section in chapter 3, where we're going to use inverses of matrices to help us solve linear systems. First thing that I want to go over before we start solving for inverses of matrices is to talk about the identity matrix. The identity matrix is if we say we have a matrix n by n, which is a square matrix, and where we get our identity matrix comes from we have ones along what is called the main diagonal and zeros elsewhere. So let's say if I just call this I as the identity equals, say I have a 2 by 2 matrix, it would look something like this. I would have ones along the main diagonal and then zeros elsewhere. If I had a 3 by 3 matrix, I would have ones along the main diagonal and then zeros elsewhere. And the reason why I'm explaining that is that if you take two matrices with n by n, and to make sure that those two are inverses, their products will make up the identity. So if I had two matrices, and I multiply them together, and if it was a 2 by 2, and if I got the product looking like this, I can assume that those two matrices are inverses. If I use a 3 by 3 and those products came out looking like this, then those two matrices would be inverses. One rule that we have to make sure of is that if an n by n matrix has an inverse, then the determinant cannot equal 0. If it does not equal 0, that means it doesn't have an inverse. So first thing we have to do is we have to determine if these matrix examples have inverses. The only way to do that is by finding the determinant. So again, we're taking some things from section 3.7. I'm going to multiply those, so it's 12 minus, would be what, 14. So then that gives me a negative 2. Does not equal 0, so that means that this matrix does have an inverse. So I just put down a yes. Here I got negative 36 minus negative 36 plus plus, this equals 0. Since the determinant is 0, I can say that this does not have an inverse. So let's write that. And here we have what is called, this is the general formula for solving an inverse of a 2 by 2 matrix. So here we have matrix A, and matrix A is brought up into variables A, B, C, D. And this little symbol right here, where it has the -1 sign, that means that that is the inverse of matrix A. That's got nothing to do with exponents. It doesn't mean A to the -1 power. It's just how they symbolize inverses for matrices. And so when I'm trying to find the inverse of the matrix, this is what we have to do. The inverse of this matrix A equals 1 divided by the determinant of matrix A, which then this becomes a scalar multiplication number. And what you do is you multiply whatever this value is to this matrix. And what we've done here is we've swapped A and D positions, and then what we've done here is we've got the opposite coefficients of B and C. So we don't so we swap D and A, but we don't create a negative to them, and then we do not swap B and C, but we just attach the opposite coefficient to it. So at the end of the day, this is the formula that we're going to use to help us find the inverse. So let's do some examples. So I have get some room. So I have example A, which I got matrix A equaling 5, -2, 8, and -3. So I want to find the inverse of this. So to find the inverse, I'm going to go, let's do, first thing I'm going to do is I'm going to find the determinant of A. So I'm going to go determinant of A equals, so what, -15 minus a -16. So this plus plus, this equals 1. So my determinant for A is 1. So to help me find the inverse of A, I'm going to equal 1 divided by the determinant A, which is 1. And then I'm going to multiply this by a new matrix. So I'm going to swap my A and my D. So this is my A and this is my D. So I'm going to swap those positions so it becomes -3 and 5. And then I have the opposites of my B and C. So this becomes a +2 and this becomes a -8. And since I'm just 1 divided by 1 is 1, I multiply all those by 1. My inverse for A is just -3, 2, -8, and 5. Okay. Again, let's look at example B. I have matrix A being 6, 1, 2, and 4. First thing I got to do is I'm going to find the determinant of A. And that comes from 6 times 4, which is 24, minus 2 times 1, which is 2, which gives me the determinant of A is 22. So now I'm going to want to find the inverse of A. So this equals 1 divided by the determinant of A, which is 22. And then I reposition my A and my D, which gives me 4 here and now 6 here. And then I'm going to do the opposite values for B and C. So I got a -1 and a -2. So now I have scalar multiplication with 1 over 22, and I'm just going to attach it to my 4, -1, -22, and 6. So 4 times 1 over 22 is 4 over 22, but in lowest terms, this becomes 2 over 11. -1 times 1 over 22, that's just -1 over 22. -2 divided by 20 times by 1 over 22 will give me -2 over 22, but in the lowest terms, that's just -1 over 11. And then we have 6 over 22, but in the lowest terms, that'll be 3 over 11. So my inverse for A ends up being 2 over 11, -1 over 22, and -1 over 11, and then 3 over 11. When we're dealing with inverses that are larger than 2 by 2, let's say they're 3 by 3, we can use our calculator to help us work things out. So here's kind of the directions that I want you to follow, and then I'll show you what it is with my own graphing calculator. So if we have, what we're going to do is I'm going to get my graphing calculator out here. So looks like this. First thing I do, I'm going to turn it on. And I want to put a matrix into the calculator. So I'm going to press matrix. And if you see right here, it's in the yellow spot. So I'm going to hit, and if you have a Texas Instrument graphing calculator like this, you're going to hit second matrix. Let's see here. Let me see if I get this to work. All right, seems I got it working. Sorry about that. So I'm gonna hit second, and I'm gonna hit matrix. And what this is, it brings up this little dialog display, which gives you matrices A, B, C, D, E, or whatever. So what I'm going to do is I'm going to go over to edit, and I'm going to find matrix A. So I can type in any type of matrix that I want. So, but what I'm going to do is I'm going to show you the examples that we have. So, so this is example A that I have here, and which is a 3 by 3. So I'm going to type in 3, enter, 3, enter. I'm going to type in these. So I'm going to go 2, enter, -2, enter, 0, enter, 2, enter, 0, enter, -2, enter, 12, enter, -4, enter, and -6, enter. So I have that matrix. My matrix A is just like my example A. So what I'm going to do is I'm going to second quit that. And what I'm going to do is how we compute that is I'm going to go back to second matrix. And then I have my one matrix, which is a 3 by 3. So I'm going to hit enter. So what that is, that brings me up to my calculator. And then you see this value here where it says x to the -1/2. That's what's going to show us what our inverse is. So I'm going to click that button here, and then I'm going to press enter. So here, from here, we're given decimal points. I don't really particularly want the decimal points. So here's how we can get them to fractions. I'm going to click onto math, and you see here where I have fractions. Click enter, and it's going to say put answers in fractions. I want to say yes, so I'm going to click enter again. So now from here, this allows us to show our matrix in fractional form. So the inverse of this is -1, -3/2, 1/2, -3/2, -3/2, 1/2, -1, -2, and 1/2. And how I can prove that this is an inverse of this function is we'll do this. Because we talked about it in the first slide, is if matrix A is multiplied by its inverse, we should get the identity matrix. So let's see if we do that. So if I go to second matrix, click A, times by the inverse of matrix A, so I'm going to go A times its inverse, I should get the identity, in which I do. So this proves that this value up here is the inverse of the matrix 2, -2, 0, 2, 0, 2, etc. Let's try example B. So if I have example B here, I'm going to go second matrix. I'm going to go back to edit. I'm going to use matrix B as my template. So I'm going to go to 3 by 3. And then I'm just going to punch in the numbers. So I got -3, enter, 4, enter, 5, enter, 1, 5, 0, 5, 2, and 2. So second quit that. Now I'm just going to clear this. So I'm going to go to second matrix again. I got B, and I want the inverse. And then this one gives me a whole bunch of crazy decimals. So I want, let's go to math. Let's see if I can get the fractions of this. And here are the fractions of that. And then you can kind of use your scroll key to kind of help you find the rest of these values. And then let's double check to make sure that this is correct. So I'm going to go to matrix. Let's go to B. And then let's multiply it by the inverse. So let's go back to matrix. Let's go B. And then click on its inverse. And as we look at, it seems like it's not the identity matrix. And since it's not the identity matrix, we can conclude that this is not the inverse. So what we make sense of is probably means is that the determinant is equals 0. So we have to make sure that we keep that in mind when we do that. So make sure when you're using your calculator or when you're using other matrices to check and make sure that the products become the identity matrix before you continue on with the problem. So next thing is we're going to be able to use inverses to help us solve matrix equations. What we're going to do is I want you to write the system as a matrix using what is the general formula matrix A times X, which X is a matrix, which equals B. Matrix X is the coefficient matrix, which we talked about in section 3.7. X is what is called the variable matrix, and then B is the matrix of constants. What we're going to do is I want to find the inverse of matrix A, and by doing that, this allows us to multiply each side of AX equals B by the inverse, which means that I can find the solution of X, or the solution of matrix X would be the inverse of A times B. So that sounds like a mouthful, so let's try to do some examples. I have matrix A, which is 3, -2, -7, and 5, and this is my matrix X. So again, this is going to be a matrix, and we know that it's going to be a 2 by 2 matrix. The reason for that is because this is a 2 by 2, and then this is a 2 by 2. In order for this product, for this matrix X to be a product of this matrix A, this has to be a 2 by 2 because these two values must be the same. And then I know that this value is dictated from here, and this value here is dictated from here. So that's where we get the dimensions from. So what I'm going to do first is I want to remember this thing. I have matrix X equals the inverse of A times B. So what I'm going to do first is I need to find the inverse of matrix A. So to remember what we have to do to find the inverse of matrix A, we must go 1 divided by the determinant of A, and then multiply it by, we're going to flip A and D, and then use the opposite coefficients of B and C. So let's do it. Let's find the determinant of matrix A. So I'm going to go 15 minus, would be what, 14, which will equal 1. So my determinant for A is 1. So I'm going to say 1 divided by 1 over the matrix so this is the inverse of A, equals 1 divided by 1. So then I'm going to flip the A and D around. So I'm going to go 5 and 3, and then the opposite coefficients of B and C. So it's going to be a positive 2 and positive 7. And then since 1 divided by 1 is 1, scalar multiplication, all of that is 1. So that means I can say that X will equal, the inverse of A will be 5, 2, 7, and 3. And this will be multiplied by B, which is -2, 4, 3, and -1. Now we're just going to multiply these matrices together. So we got to use our rules that we made from in section 3.6. We're going to, we have, again, a 2 by 2 matrix, as we already talked about. So that means this is row 1, column 1. So I'm going to use row 1 in my inverse, and then I'm going to multiply it by B. So this gives me -10 plus 6. Now I'm using row 1, column 2. So this will give me 20 plus a -2. I got row 2, column 1, so this becomes -14 plus 9. And then row 2, column 2, so I have 28 plus a -3. So when I add these together, this matrix becomes -4, 18, -5, and 25. So let's see if that works. So let's do this. Let's go back to our calculator. So turn it on. So if I go back to second matrix, let's edit A. And so let's say that A is, this is a 2 by 2. And then A is going to be 3, enter -2, enter -7, and 5. Second, quit that, and then let's put as matrix B. Let's do like B. And oops, clear that. I need to edit B. So this one's another 2 by 2. And my matrix D is actually, I'm going to put in the values that I got for X. So I'm going to go -4, enter 18, enter -5, enter 25. And in theory, if I'm correct with these values, I should, if I multiply these two matrices together, I should get -2, 4, 3, and -1. So I'm going to go A times matrix D, and that holds true. So that proves that my X value was correct. So now, as I go to the next example, let me get some more room here. I am going to use now a system of linear equations in order to solve for this particular. I'm gonna use the inverses to help me solve x and y. So first thing I want to do, and just try to reiterate. So I want to write my system as a matrix. So that's step one. So let's just put a little 1 right there. So that's step one. So first thing I want to do, like we talked about on top of the screen, we're going to have matrix A. That's going to be the coefficient matrix. So we're just going to put down the coefficient. So it's going to be -2, 3, 5, and 1. For my matrix X, that's going to be my variables matrix, and it's represented as X and Y. And then it equals my constant matrix, which is B. So, and that would be -11 and 19. So here we got A times X equals B. And again, we said that X ends up equaling the inverse of A times B. So what I need to do first is I need to find the inverse for matrix A. By doing that, I need to find the determinant for A. So I'm going to go -2. So I'm just going to write determinant for A. So it's -2 minus 15. So my determinant ends up equaling a -17. So now when I find the inverse of A, that equals 1 divided by a -17. And then my matrix here will have, I flip my A and D, so I'm going to have 1 and -2 here. And then it's the opposite values for B and C. So it's going to be a -3 and then a -5. Now I'm just going to use scalar multiplication to find the inverse. So then it's going to be what, -1/17, +3/17, +5/17, and positive 2 over 17. So that's the inverse of A. And now I can take this value and say that put this down here, I can say x and y will equal the inverse of A, which is negative 17, 3 over 17, 5 over 17, and 2 over 17. The product would then equal, what is it, negative 11 and 19. So I'm going to find the products of these. And now I know that this is a 2 by 2 matrix, and this is a 2 by 1 matrix. These are the same, and that means that this matrix here is going to be a 2 by 1. By 1. Let me erase that. 2 by 1. Sorry about that. So I'm going to use my multiplications. So I'm going to take my first row in my inverse matrix, turn it on its side. So that means that the first values there is going to be positive 11 over 17 plus would be what, negative 50. Let me see here. Oh no, it would be positive what, 57? Yeah, 57 over 17. And then to get my second, my row 2, column 1, so I'm going to use row 2 of my inverse, and then going to use column 1 of my constant matrix. So I got 5/17 times 9, or negative 11, which gives me what, negative 55 over 17, plus what, 217 times 19, so that'd be what, 38 over 17. And then if I take these and add these together, 11 plus 57 equals what, 68. 68 divided by 17 gives me 4. And then negative 55 plus 38 gives me a negative 17. Negative 17 divided by 7 will give me a negative 1. And we can plug that back into the original system, see if it holds true. So this is my x and this is my y. So 4 times a negative 2 is a negative 8. Negative 8 plus a negative 3 is a negative 11. That holds true. 20 plus a negative 1 is 19. Holds true. So x being 4 and y being negative 1 is a true statement. So that'll allow us to another way for solving another system of linear equations. And this will conclude being able to use inverses for matrices and also, again, solving systems of linear equations. Hope this helps. Until next time.